Hello, everyone. My name is Steve Ray, and welcome to, I guess it's the November 15th talk in the TOCS series, Talks on Computer Systems. I'm standing in for Ted Selker, who's in China, I think, today, or heading that way. Today, we are honored to have Adam Pease of Reardon Commerce, who's going to talk on his ontologies in general, and in particular on formal ontologies and the suggested upper merged ontology, SUMO, which is his brainchild over these many years. I've known Adam since over a decade anyway. I'm trying to remember when I first met you, but it was in the 1990s sometime when I was getting into ontologies as well. And he's obviously one of the big names in ontologies and has been nurturing his SUMO ontology for many years now. I'll let you give your old bio and background, but suffice it to say that he's been working in this area for several decades and knows formal logic better than most of us, certainly myself. So Adam, I'll let you take it away. Oh, a couple of logistics real quick. In the room, we've turned on all the microphones to always be on, so any taps you make on the desk will be duly recorded on the recording. So appreciate that. And if you would like if anyone's dialing in, listening remotely, put your questions on the chat, and I'll be happy to sort of relay them to Adam at the end of his talk. We have a hard stop at 2:25 to let students come in at 2:30, so we'll try not to delay any longer. Adam.
Great, thanks, Steve. I appreciate the introduction. So everything I'm going to talk about today is open source. Even though I work for a commercial company, I've spent the last decade developing SUMO and its associated tools myself, and they're all free, and they're all available at ontologyportal.org. So I work for Reardon Commerce that has a platform they call Deem, hence the gigantic advertisement on the front page, that is our e-commerce platform. So I probably won't get through all of my slides, but I will do my best. So first I'm going to start out with, what's this stuff good for? What are our current applications? So semantics, and by semantics I mean expressing formally things that people know about the world in a language that computers can actually deal with, as opposed to just straight text, for example. Semantics has a number of different applications. So one is structuring databases. That's probably the easiest way to adopt formal semantics. So naming things in our world, creating precise definitions for them, and then just using those definitions as a better data dictionary than current methods where you might have English names for fields and English definitions for those fields. Instead, you can define them in formal logic consistent with a large upper ontology. And that's actually what a large part of my prior consulting experience was before I joined Reardon Commerce this past March. Another thing that's possible is exposing features. So if you're doing analytics-based stuff, machine learning, a large part of that work is exposing the signals that you have about the world in a way that's appropriate so that your methods can actually learn what the correlations and classifications are. And ontology gives you all sorts of new tools for exposing features in different ways and summarizing features. Capturing knowledge is a key thing. So expressing things in a computable way such that you can do inference. I actually have not done a lot of application with inference, but my research activities are very much concerned with theorem proving and formal inference and various sorts of logics. So in terms of database structure, here's just a little trivial example taken from what we do currently at Reardon Commerce. So our work is corporate travel. So we have suppliers, information suppliers that give us data about hotels. And they describe things in dramatically different ways, and we need to canonicalize all that thing. So it could be as simple as the room has a particular 120 or 220 volt power source. We create a single term that gives you that information in a standard way. We define it formally so it's very clear to people in the future who are linking up different suppliers that are referring to the same thing to know that they're linking to the correct stuff, and just be able to go from there and have our databases refer to things in a consistent way, and to have the definitions not just in ambiguous English that people can misunderstand or interpret in different ways, but have it described tightly and formally so that there's sort of no room for guessing about whether the thing that you want to map into the database actually fits in that particular slot or not. And Reardon Commerce also, like I think a lot of older companies, so Reardon is about 10 years old, has databases that have, I think at last count, over 17,000 different fields that have evolved as we've gotten into different vertical domains: hotels, flights, expenses, product purchases, tickets for events and shows. Each one of these has wound up being created as a sort of semi-autonomous vertical application without a lot of commonality and not a lot of real attention to creating a common data dictionary. Something like only 10% of our fields are actually given precise English definitions. So about 1/3 of our fields are probably redundant. Another third are completely unused, and it's only that remaining third that's actually under active development, and no one developer actually knows the answer to which fields are the ones that we're supposed to keep around and that are correct. So one of my goals is to help with that. Another thing we've done in terms of a near-term application is in sentiment analysis. So sentiment analysis refers to getting the emotional content of text. So basically finding all the adjectives and totaling them up, giving them a score, and that gives you whether somebody's saying something positive or something negative in a particular snippet of text. We also do some concept extraction, so connected with the ontology that I'll be talking about in considerable detail in a moment. The notion there is that we don't just give a summary score for text, but we can actually say that a person is, say, very positive about the cleanliness of the bathrooms at the hotel, but maybe very negative about how comfortable the bed is or how uncomfortable the bed is, as opposed to just having a positive or negative review overall. That detail is important if you're a traveler. So not state-of-the-art stuff that we've done so far in terms of linguistic analysis, but very useful. So a little more detail on sentiment finding. And some of this will make more sense in a moment as I discuss in more detail what the ontology brings. But here's just a sort of architectural overview. So imagine, question, yes?
This is a silly question. As a non-ontologist, what's an upper ontology versus any other ontology?
Can I get into that when I actually go into the technical details? I do have a section on that. Okay. So I'm sorry, there's always the challenge about do I present the science first or the application first? And I found that often people are sort of unmotivated by some of the science, and so now in my talks I give the applications first. So yes, some of this will be probably unclear for another dozen slides. So imagine you start with a review like the guest rooms are somewhat shop-worn or downright shabby. Two of the adjectives are shabby and shop-worn. We have a big list that scores all the adjectives. So shabby is a strongly negative, -5 score. The scorer just totals up the occurrences of all these words and gives an aggregate score for each sentence of our text. In parallel with that, we have a big corpus where most of the graduate students have had to go through the million-word brown corpus of English, one word at a time, saying this word is this particular sense in the WordNet dictionary, as opposed to this other sense, 4 words that are polysemous, or words that have multiple meanings in the dictionary. So we do some word sense disambiguation based on those statistics. So for example, we can differentiate between room in a building versus the sense of room to grow, room as space. So we can total up the co-occurrences of senses with other words in the sentence and make a guess about which word sense is being referred to. So we can decide on room in a building being the sense that applies here, and then we can tag the concepts that we extract from a sentence with the sentiment that also occurs in that sentence, and therefore conclude that for a particular hotel, so the San Francisco Drake Hotel in this particular example, that has a certain number of reviews. In this one review where this sentence occurs, we can give room a -6 sentiment. And then by totaling up all of the reviews that we have for all of this same hotel and all of the sentences that appear, we can then aggregate this content and find out that if 25 people say that the room is shop-worn, shabby, dirty, annoying, noisy, all these other negative things, then the San Francisco Drake Hotel gets a very negative sentiment associated with it with respect to the quality of the room, as opposed to amenities, the quality of the lobby, the spa, the pool, etc. And that gives travelers a much better insight into what they should care about in terms of their hotel choices, as opposed to just saying this hotel is good or bad to some degree. I'll skip analytics. So from a science standpoint, I also want to highlight things we've been doing very recently. So we've done a lot of work mapping to very large fact bases. So Yago is one of these, yet another giant ontology that extracts a lot of facts from Wikipedia. Now all that factual content is amenable to formal logical inference with all the axioms that are in SUMO. We've done a lot of work mapping the formal ontology to the linguistic content that's in the WordNet dictionary. I'll talk about what that means in a moment. And we've also done quite a bit of work on our integrated development environment for SUMO that helps us develop these ontologies in the first place. Okay, so now that we're done with the motivation, let me get to some of the science about what is all of this and why is it better than possibly some other approaches. So some general concepts first. So this is a kind of common slide in ontology talks. So the idea here is that there are three things that we could pay attention to in the world. There are things in the real world, oranges, that we're calling reference. There are terms in various languages or symbol sets for that referent in the real world. So in English, we call it an orange. And then there are concepts. And concepts I take to be the sum total of knowledge and experience about this referent or this class of reference in the real world. And a lot of ontology work, unfortunately, I find is really at this level of creating hierarchies of named things and then using human intuition, the things actually in our heads, as proxies for definitions of orange. So just assuming that if I name it and I name it as something reasonably correct in English, that all English speakers will naturally have the same intuition about this word and use that ontology in a consistent way. And of course, that's not true. It doesn't actually work that well. But that's what most people are doing. So what I'm doing is attempting to come up with a very imperfect but still useful analog for human thought. And what we use is a variant of mathematical logic, first-order logic with some higher-order logic extensions. We can say just about anything we want to say in logic that we could also say in English, for example, or any other human natural language. So here's another perspective on this. So imagine you're a human being going to a website, you see the stuff in black, and you can do the markup in your head that's in red here. That we know that Case Western Reserve is a university that we've heard about before. We know this is personal information. We know that Joe Smith is a common Western name. Great. People can read web pages. So apologies for any Chinese readers in the room. So this slide only works if you don't know Chinese. But the idea here is that if you're a computer, what you see is just a meaningless collection of characters. You don't actually know what these things mean. You have to have recourse to some sort of other process to actually create this markup that's in red. But wait, we've got XML. Everybody thinks XML is going to solve this problem. We just do this sort of markup and structure our data. So now we know that Joe Smith is a name and his title is a programmer. Of course, what the machine sees is this meaningless collection of symbols that now just have some syntactic arrangement to them. A lot of people are excited about taxonomies. They think taxonomies are going to solve this problem. So great, we can specify that Joe Smith is more specific than person. Person is more specific than mammal. Of course, what the machine sees again is this, a meaningless collection of symbols in this more general, more specific relationship. Well, now we've got the semantic web. Great, we've got semantics. We've got a little bit of semantics. We can do some very simple things that if in the semantic web with its syntax, which is of course a little different than what I'm showing here graphically, we can state that Joe Smith is an instance of person and person is a kind of mammal, and that if all of the conventions and definitions on the semantic web languages are followed, if you have an application that conforms to those conventions, you are entitled to make this deduction, this one very simple deduction. If an individual is an instance of person, person is an instance of mammal, then that person is necessarily an instance of mammal. Great. That's the sort of thing a person could do. And of course, what the machine sees again is this, but the machine is making an inference that if you attack the symbol grounding problem and you attach each of these meaningless collection of characters to something that is a more intelligible referent, then the machine is doing a sort of parallel inference. It may not know what it's doing in any deep sense, but it's doing something useful. It's doing something sort of human-like. Of course, the challenge here is that this inference is not very interesting, and the set of symbols isn't very interesting. So you need to have a language that allows you to say pretty much anything you would want to be able to say, and an inference process that allows you to do inference with any of these statements that you may create, and also to have a lot of these statements to begin with. Because if you only have 3 statements, well, gosh, your inferential power there is pretty low. There's not a lot you can conclude. So a lot of my work has been in this area of creating a lot of content that we can do useful things with. And not just instances, but rules about how our world behaves. So we don't have to argue about whether this is actually intelligence or not. Let's just say, it looks like one tiny part of human intelligence. If it does something useful, that's a good thing. So we need to be able to state anything we want to about our world, and we need to have accumulated lots of knowledge stating lots of things that we can reuse. So let's look a little bit at some other ways of doing this job that people have tried in the past. So one way is frame languages. Frame languages are old style AI. A lot of people, in fact, still do work in this. In fact, you could argue, and I do argue, that the semantic web is largely just frames all over again. So for those of you not familiar with this sort of notion, frames are object or term-centered representation, very similar to object-oriented programming. So we have things in our worlds, instances. Instances are members of classes. These classes have slots defined, and when you have an instance, you can fill in the values on those slots. Simple, straightforward, easy to grasp. There are, however, some very serious problems with this. So when somebody comes to me and they say, oh, I'm a semantic web enthusiast, I believe this is the right way to do things, the first question I usually ask them is, okay, so represent between for me. Okay, between is fundamentally a relationship amongst 3 things. B is between A and C. Well, if all you have is a frame language, all you have are binary relations. That's a problem. Right? So if I want to say B is between A and C, there is a way to do it with only binary relations. It's very unnatural. It's very awkward. Here's the details on how to do it. And so as a result, nobody actually does this. And so if you look on the semantic web, you won't see any ternary relations that look like this. You won't see between this. Now, to me, that says, here's a language that's insufficient for representing knowledge about our world. If that's something so basic that it fundamentally can't represent it, I don't understand why it's actually taken all that seriously. So there's my conveniently, yes. However, that's the convenient part. Yes, there is a way around it, even though it's awkward and nobody does it in practice. There are other things that there is no way around, right? So if you want to negate an arbitrary expression, I want to say that Adam is not an account. Now, there's also sort of a workaround for this. I can take every relation that I have about the world and create a sort of bogus invented negation version of that. Okay, I've doubled all of my number of relations. However, if I want to say something more complex, that Adam is not a 47-year-old Indian national that was born in Calcutta that is an accountant, there isn't any way to negate that whole arbitrary expression. You have to invent a new language, and so people on the semantic web are inventing new languages and having negation that can operate on whole named graphs. But at least in terms of the actual fundamental capabilities, you can't do that. Also problems with existential and universal quantification. I'll talk about that in a moment. Description logics in general have this problem. They do, however, have very efficient computation, and that's often the selling point, that you lose all this possibility of representing things in the real world, but you get the advantage that it's really fast. I don't think that's actually a good argument. I'm going to talk about in a moment why. More stuff, maybe not quite so important, but frames also have an issue with focus in terms of relationships, that you have slots on frames. They're tied to frames. Well, relationships in the real world are not just tied to any particular entity. If it's a binary relation, it's equally tied to all things. So why isn't my occupation a relation between a class of occupations and the individuals that fill those occupations? If you want to look at it that way, in a semantic web language, you have to create inverses for it. You have to create occupation inverse. Again, doubling all our numbers of relationships and losing that semantic tie. Every time that you create a sort of redundant thing, you're losing standardization that is one of the whole original points of ontology anyway, of localizing information in one place and defining it precisely, and not having synonyms all over the place, and the possibilities for confusion, possibilities for things to get out of sync. So here's just some examples. You don't necessarily have to read the logic, but just to get the point, here are two kinds of quantification in logic. Universal quantification. All farmers like tractors. For every such and such, for every F that is a farmer and every T that is a tractor, F likes T. And that's a very different statement from saying some farmer likes a tractor, or so there exists some F that is a farmer and some T that is a tractor, and there's this relationship of liking between that farmer and that tractor. Totally different thing to say about the world. Languages, if they want to represent formally things that we say in commonly all the time in English, our languages, our formal languages, better be able to capture that. Let's take it a step farther. Now, those were really simple things, things that we have in first order logic. If we want to say a lot of other common things, such as statements about belief or knowledge, we're in a higher order logic of some form, or a specialized logic, like a modal logic, or a doxastic logic, an epistemic logic. There are all these esoteric variations, but they're all beyond first order. So if I want to be able to say that Mary believes that John likes Sue, we're relating a term, Mary, to a formula that John likes Sue. Something you can't do in first order, and you certainly can't do in a description logic like any of the semantic web languages. And yet these are ubiquitous sorts of statements in human communication. So the conclusion I get to from all of this is, yes, there are some challenges in reasoning with very complex expressions, but just because we haven't figured out how to reason, in millisecond time on arbitrarily large systems with this sort of knowledge doesn't mean that we should put ourselves in a straitjacket and say we'll never represent these things at all, never capture this knowledge about the real world. Because in fact, there are all sorts of different applications, and you can see that here in my work at Reardon Commerce, that right now we're doing some very complex things that we can do as a batch process over the span of several months. So it doesn't have to function fast. As long as we can pre-compute things, our application constraints and requirements for speed are dramatically different. Now, if we're doing something in click time, well, absolutely, we need a description logic, or probably not. That's going to be way too slow, too. We're going to need just some sort of lookup table or pre-cache all our answers. So I think there's two different things. There's the application of knowledge, and there's the creation of knowledge. And so we can create and define things in the real world in a very expressive language. And then if our application has certain constraints, we don't have to use everything that we defined, but at least we've got it there if we have an application that needs it. And we can use that knowledge about the world, these extra definitions, to show that the things that we've said are mutually consistent with one another. I mean, one of the big problems that taxonomies have is as they grow, there's no way to determine whether they've actually been created in a way that's even internally consistent. You find this with standards. So Steve and I have talked about, PDES STEP as a sort of canonical case of an enormous standard that's probably thousands of pages long. How do you know if that standard's correct? Different people have authored different sections. There's no way to prove that it's consistent. One person can't say, oh, authoritatively, that statement on page 15, of course, is consistent with every other page, including page 1027. It's humanly impossible. But if our standards were defined in mathematical logic, where our definitions, everything that's in an English standard was actually put in mathematics, then we could actually prove that it's correct. We could have a machine run over all these statements and determine that there's no internal contradiction. Now, that's actually possible because it is what we do today already with the SUMO ontology. We know that it's, for the most part, right. There are some wrinkles there mathematically that I can go into at another time or offline. Yeah. So open source is a good thing. Do everything open source. We gave SUMO away right from the start. People have helped us with it. People can adopt it easily. There's no licensing issues. And amazingly enough, I found this spring that companies are willing to deal with this and able to deal with this thanks to software as a service as a metaphor. And I could talk in some further length about how open source can work very well in a commercial environment. So don't believe the fear, uncertainty, and doubt promulgated by people that like to do proprietary software only. Upper ontology. Okay, now we're back to this gentleman's question. What is an upper ontology? So upper ontology is an attempt to gather the most general and reusable terms and definitions about our world. So this has a number of effects. So one is just provoking thought on clarifying the meaning of terms. If you create an ontology from scratch, it's totally unanchored to everything. The decisions you make are just with regard to your knowledge about the rest of the world and your intuitions about what you've created so far. There's not a lot that you have to sort of pay attention to in terms of the model building. But if you're extending a model, the very first decision you have to make, I've got this new concept. Where do I put it? What leaf do I attach it to in my giant hierarchy? You've already made a wealth of decisions that clarifies exactly what you mean, even before you've done any other definition. Just by attaching it as a subclass, you've made lots of decisions. It also provides for large-scale reuse. So this is something that I can't overemphasize. So modern software development, for other than a few sort of pathological cases you could dream up, nobody creates their own operating system, device drivers, database systems, just to write a web application that's going to serve up travel results, for example. Right? Reuse is a fact of modern life in software engineering. But amazingly to me, very few people actually reuse much information. Right? They're always creating their own ontologies, essentially. And those ontologies, with all their built-in assumptions, are always going to be inconsistent with one another. So I think that formal ontology leads us into the modern age in terms of information representation, so that we at least have some of the advantages of modern software engineering. So why use an upper ontology? What's it good for? So, yes?
So how does that relate to psych, for example, which was an effort to collect lots of knowledge in a common form?
Yeah, so
all the world's knowledge, if I remember the phrase.
Right, so psych is a noble effort that predates SUMO. They were actually a subcontractor to me on a big DARPA program, and I was very frustrated when that program ended that I no longer had access to this thing that I thought was so wonderful, and so I made my own. SUMO's open source, psych isn't. Sure, it's big and it's good, and I think they had the right idea in many ways, but I think ultimately, from a business standpoint, business process, they didn't have the right idea, because both SUMO and psych are much smaller than they need to be. And what we need is a Wikipedia for ontology, where everybody's contributing their own little ontologies, be it smart grid stuff, or weapons of mass destruction, or travel, or any other topic you can imagine. The world is too big for any one company or organization to create a single, coherent, consistent ontology. But with SUMO, now everybody can contribute. So, what's it good for? So let's say we had a couple of businesses that are very diverse, very far apart from each other, 1-800-Flowers and Harley-Davidson motorcycles. However crazily different those businesses are, both actually have a considerable amount of stuff in common. They both need to send information to FedEx. They both share notions, common sense notions of weights, dates, dimensions, deadlines, so forth. And so the alternative right now is mapping, right? So if you want to connect your information systems, you have your programmers go through the two representations, try to match them up, creating some special purpose interface code to convert one representation to the other. Very intense, difficult, and error-prone process, and a very expensive process. Now, there's always going to be legacy systems for sure, but we're so much better off if people start by sharing a model, sharing definitions. And a formal ontology that's as comprehensive as SUMO gives you a way to do that. Now, there are people that have claimed, especially early on the semantic web, that, oh, we'll let 1,000 flowers bloom, everybody will create their own, and we'll just map later. I don't think that works in practice. It's very hard. Anybody that's tried to map two ontologies has a real challenge with it, usually because the definitions are so thin to begin with, you don't know what the original person meant. It was clear to him or her at the time, but it's never clear once you're actually doing that mapping. So people have occasionally claimed that it's not possible to have a common upper ontology. I vehemently dispute that because I think both, one, by existence proof, we've shown that it's possible. But I think fundamentally it relates to a confusion amongst three different things. There's ontologies, which I believe are sort of expandable, language-independent, machine-understandable things that people construct. There's language, which languages are things that have evolved organically and informally as a social process. They're meant to be understood only by humans. They are necessarily ambiguous. And then there's knowledge about the real world. And people can share ontology and not share language and not share knowledge. In fact, any combination of these three is possible. So as a sort of silly example, take the case of two groups of people. One believes in unicorns and the other doesn't believe in unicorns. They can still share an ontology for unicorns. They can still share the definition for what a unicorn as being a horse-like object with a single horn coming out of its head. And yet, one group can say there does not exist at least one, and the other group says there exists at least one. That's down in the realm of knowledge, not down in the realm of ontology. So we can disagree about many things. People disagree about many things, and yet they can still share common understanding enough to communicate with each other, common definitions. And of course, people that speak radically different languages can still share an ontology, and do share an ontology. Otherwise, we couldn't really do translation. So here's some detail about SUMO itself. So SUMO started out as just an upper ontology. The name is kind of a legacy now. It's really far more comprehensive than just an upper ontology. Initially, it had about 1,000 terms and a lot of logical statements. One early thing that we did was to map it to all of the WordNet dictionary, the WordNet electronic dictionary. That's I'll talk about in more detail in a moment. We've kept it upgraded as WordNet itself has evolved. We now have domain ontologies that total about 20,000 terms, 80,000 axioms, so it's very comprehensive in a wide range of different knowledge areas. Just been doing some new work in hotels, dining, products, offers, points of interest, a lot of things related to travel. It's all free. SUMO's formally defined, so although we have an open source tool set, you can use it independent of that tool set. There's no mystery in what things mean. It's got a formal definition of the logical language so that you can interpret it independently of the application. Application itself is free. It's on SourceForge. I encourage you to download it. It's fun to play with. I'll give you a hand if you need it. And lots of people are using SUMO, so the pubs page is actually kind of out of date. I just rely on Google Scholar now. There's some, I think Google Scholar gives something like 1,200 different citations, academic citations for SUMO. So it's pretty well known. I'd say about a third to a half of those references are cases where people are actually using SUMO as opposed to just giving it as a related reference. So a lot of people are doing stuff with SUMO. Early on, people claimed it was monolithic. It's not. It never has been. Even the upper level has this kind of modular structure, albeit with some necessary dependencies among them. Now there are lots and lots of domain ontologies, as I mentioned. It used to be tilted very highly towards military applications because those were my customers. Now you're seeing a lot of stuff about travel because that's my newest customer or employer. People often ask, why is SUMO any good? How do you know that it's actually we've made the right choices and the right definitions? Well, first we had this mapping to all of WordNet. So early on we had whole areas of knowledge that we just hadn't thought about before we did the mapping. And we found that, well, we're trying to hook in this sense from the dictionary, and we can't find a good home for it. It just links up at the root entity, the class of all things, and that tells us, well, something's missing. We need some extra definition to be able to map to this word in the English language effectively. So it was an excellent check on coverage and completeness. Peer review was key. People love telling us how SUMO is all wrong, and sometimes they're actually right. And they find things in there that are bugs or typos or thoughtless definitions, and I can fix it. So it's difficult having peer review all the time, especially on early versions of things, but gosh, is it useful. Formal validation, I've alluded to in the intro. So once you actually have things in mathematics and you have theorem provers, you can check for consistency. Now, there are some technical limits, so it's an NP complete problem to actually prove consistency over a first order logic thing. So we can't guarantee that there isn't a contradiction lurking deep in the bowels of some 100-step proof, but we're pretty confident that there aren't such things because we just run this sort of test continuously, trying to find problems, and automated theorem proving has found lots of problems over the years, and as theorem provers get better, we find more and more things. In fact, very recently, the vampire theorem prover had some pretty amazing improvements and found about half a dozen problems that had lurked unfound for years in SUMO in terms of logical contradictions. So very useful. And then every time we go to a new domain, we discover new stuff. we create upper level content that we missed before, or maybe that was correct or too limiting, or we can abstract a little better, make a little more general. So what's WordNet? WordNet, if you're a linguist, every linguist knows about, every computational linguist knows about WordNet, something that Princeton created, I think almost 20 years ago now. It was my model for how to do research, because they gave away every version from the start for free. And as a result, it's a de facto standard in computational linguistics. And it's just a wonderful product. And it's been used in ways that the originators could never have imagined. The same thing has happened to an extent with SUMO. That's a really beautiful fact about open source. So how are SUMO and WordNet different? All right, some people do misuse WordNet as an ontology, and I think that's problematic. So let's take the case of the relationship earlier. So here's a very simple axiom from SUMO, and this is often a challenge. I show an axiom for SUMO, and people look at it and say, well, gee, that's pretty boring. And you know, it is boring. Yes, any sort of atomic element of human knowledge is going to be boring, but it's this accretion of tens of thousands, hundreds of thousands, millions, and ultimately billions of little bits of knowledge that actually will wind up giving a machine common sense in some definition of common sense. We could sort of argue that at more length some other time, but it's clear to me that we need a lot of stuff like this. There's other things we need as well in terms of creating human intelligence. But we certainly need stuff like this. The notion that, you know, if we have two intervals, one is earlier than the other, that the beginning point of the second interval is after the end point of the first interval. Now, WordNet has the English word earlier in its system, but it doesn't have this definition. There's nothing that would allow somebody using WordNet to actually reach this conclusion that the start here is later than the finish here. Right? So they're complementary. It's not a criticism of WordNet, but we need both language, human language, and we need formal definitions about how our world works. Lots of internationalization, mostly done by volunteers. We could talk about that at some later point. Lots of nifty languages, including Arabic. I did a big project on Arabic for the Defense Department. So creating an Arabic dictionary, mapping SUMO to it, creating lots of definitions about Arabic-specific cultural concepts, creating those definitions in SUMO. People ask occasionally, are SUMO terms directly usable? You know, wouldn't it be easier just to create the domain ontology that I need right now? And so we did a study actually with Psych years ago, now before SUMO even existed, and when I was still working on Psych, to look at, in a large test suite, we had about 500 test questions we had to code up in logic and then answer questions that were posed to us by a government representative. And so then we could look at the proofs of the answers that we got and run some statistics on them to see how often were concepts that appeared in the proofs things that came from the upper ontology. And we found that about 1/3 of the time they were from the upper ontology. Now, to me, this wasn't at all surprising, right? How can you say much of anything about the real world that's more than a toy example without talking about that something happened before something else, or some entity was the performer or the agent of a particular process? These are ubiquitous things in human communication, and so of course they're also ubiquitous in any non-toy ontology. I've alluded to this already. Why just one upper ontology? Well, translation is hard. There could be lots of these upper ontologies. You know, find one good one, pick one, and then stick to it, and then try to map everything to it and extend it. Just to emphasize the notion about ontology and language being different, I had one person that, you know, argued with me, and they said, you know, SUMO's definition of landing is just wrong. You know, what about landing a boat? Well, the point is that, yes, English has a sense of landing, which is landing a boat rather than landing a plane, but an ontology is not language. It is a thing that we construct by fiat, and we say, the concept, the notion of landing a plane is the thing that we are going to name with an identifier landing. And we'll have another term for landing a boat on shore, right? That's going to have a very different definition than this logical definition, which just talks about atmospheric regions and flying. Okay, you need both, but they're just defined differently. You know, SUMO terms are like variable names in a program. They're meant to be evocative and helpful, but they are not the definition. The definition is not in the name. It's not in your intuition of what that name might mean. Just like a program, the definition is in the axioms, or, you know, in the Java method, if we're taking this analogy on the other side.
Would you have a connection to other meanings of landing? Sort of like in a thesaurus or in a WordNet or something?
Well, there'd be connection in WordNet. And so if you look up in WordNet landing, and you'll get these different senses that will map in turn to completely different SUMO terms. What they'll share in common in SUMO are things like the definition of instance, holds during, end fun, the processes. Instead of flying, it will be water travel, and flying and water travel are both cases of translocation. So there'll be this connection, but it won't be the simple binary connection like through a semantic network. It's a far more nuanced connection through these detailed logical definitions that, unlike a semantic network, doesn't lose this information about the real world. It captures all of it, ideally. Okay, so on to Sigma, the tool set. So it's an integrated development environment for SUMO. It's also free, does lots of things, mapping, merging, and translation. So we talked at lunch today a little bit about ontology mapping. So we do have some tools for that. It's hard. You can't do it automatically, but tools can certainly help speed up the process considerably. Lots of things for browsing and display, just like any, like a modern IDE like Eclipse helps you sort the Java class hierarchy and look at it in nifty ways. Of course, we have that as well. Analysis and debugging, so doing consistency check, things like theorem proving mathematically, or trying to prove mathematically that the ontology extensions you've created to SUMO are correct and consistent with the rest of it, and inference, question answering, basically. So maybe I won't go too much through the tools. That would be a topic for another time. Here's just an example of what you see when you look at the Sigma browser at SUMO. You see a particular term, walking, a bunch of words in WordNet, or word senses that are referred to initially by words in WordNet. You see some pictures, which I think is kind of cool. So I actually used Amazon's Mechanical Turk one year to hire people to link Wikipedia images to SUMO concepts. So a vast number of SUMO concepts now have associated images, which I think should ultimately be useful for things like image recognition, but no one's taken advantage of it yet. So right now it's just kind of a nifty feature. You'll see an English definition that's just, again, like comments on a Java program, not the actual definition, but helpful, useful to a consumer of SUMO, just like comments are on a computer program. And you'll also see these full formal logical axioms defining what it means to be walking. And it's this, not any one axiom, but it's the collection of all the axioms that include the term walking that give it its full formal definition. Also see on the right that we attempt to do a natural language paraphrase of every axiom. So we have some an automatic tool in Sigma that creates these expressions. And we can create them in a host of different languages, including Chinese and Hindi, Italian, German, etc. Let me just skip the consistency check and inference. Just a word about inference engines. There's been this tremendous community, largely European-based, that for years has worked on doing automatic inference in first-order logic. And it used to be fairly obscure stuff, and I guess it still kind of is fairly obscure stuff. It's usually, a conference happens once a year. There are maybe 100 people, usually less, very heavily mathematical, but now this stuff is actually getting practical and useful. So for the past 4 years, I've been sponsoring a competition that is a subcomponent of the yearly theorem proving competition. It's called TPTP is the suite of problems, thousands of problems about theorem proving, and it's the Conference on Automated Deduction, and the CADE automatic, let's say CASC. It's the CADE automatic systems competition, so it's automated theorem proving. There's a whole suite of thousands of problems that are thrown at different theorem provers to prove which one is the fastest on different classes of problems. And they've been working on theorem proving, but not theorem proving in the large, theorem proving on knowledge bases that are big like SUMO is. And so over the past 4 years, we've gone from the first year I sponsored the competition, the suite of problems we threw at these provers, most of them couldn't be answered. And the ones that were answered took 200 seconds to come up with a proof. This past year, the same problems are now too easy. We've actually made them more difficult over time by we started out just having them do proofs with just the upper level of SUMO, just the upper ontology. And then we kept making it harder. Then we added the middle level of SUMO. And then we made them answer questions over the entire set of domain ontologies, all tens of thousands of statements. Now the problems are too easy. So the best provers answer them in less than 3 seconds, and they answer all of them. So, many orders of magnitude improvement just in the past few years. So this stuff that people have thought is kind of impractical, for full first-order logic theorem proving with equality, is now eminently practical, even on very large knowledge bases. We do lots of stuff to make all this work with these different provers. They weren't designed to work with SUMO, so there's some interesting research there. I won't talk about that in detail. Here's just an example of the screenshot you get if you ask a very simple query. You get this nice linear kind of proof, just like you would in any logic textbook, that lists each statement and then justifies or supports that statement. So either it came directly from the knowledge base, or it was deduced by refining, step 4, or in some cases multiple steps together. So just gives you an explanation. 10 minutes to go. Okay, so we will just go as long as you'll let me. I don't know if you want people to interrupt or just stop at a certain point to leave time for questions. People are not being shy, so that's
come
good.
up anytime, and we can also have discussions outside.
Right, so be incrementally less shy as we get closer to the deadline and interrupting me. Pitfalls. What a lot of other people do wrong, I think, with ontologies. Because lots of people are doing ontologies. I mean, this is a crazy thing. So 10 years ago, I'd give talks on ontology, and people say, oh, so what kind of cancer do you specialize in treating? And so now I get questions of, oh, ontology, semantic web, yeah, I know what that is. And usually I find that people don't. Ontologies become a synonym for good. Things that were just class diagrams or database schema, now people are calling ontologies because that's the cool buzzword. Right, so I mean something fairly specific by ontology. I mean descriptions of things in the real world that are made in a formal mathematical language. So not just taxonomies, not just thesauri, not just data dictionaries, but things that are intended for computer consumption and computer understanding without recourse to a human in the loop, to imbue the term names with the human's intuition of what those things should mean. So what are some common mistakes that people make when they are creating these informal ontologies for the most part? So here's one: instance versus subclass. You'd think this would be utterly fundamental, that, well, we all know what an instance is, so Bob is definitely an instance. Bob, the one human, is an instance of mammal. Human is a subclass of mammal. And yet, the #1 cited introduction to ontology creation that you get on Google gets this wrong. So this mistake is shockingly common and being promoted as a solution, unfortunately. It's a little harder when you get into unusual things like this. This one actually threw me 15 years ago when I first encountered it. So Streptococcus is an instance. Well, no, it's not, because an individual Streptococcus is an individual bacterium. Streptococcus is essentially a collection, a class of these bacteria in a human body. And of course, then there's additional, here's another example of where language can trip you up, because we actually talk about strep as being a condition that you're afflicted with. And there's ambiguity between, is it the condition or is it the actual strain of bacteria? So the moral of this story is, if you only have one type of link, you wind up mixing them. So if you're just creating a taxonomy that doesn't even distinguish between instance and subclass, you're guaranteed to make this mistake. So let's take a case of where you actually have a language that will allow you to distinguish between instances and subclass. I get this very frequently, part of versus subclass. So a lot of people will misuse the subclass relationship as though it was part of. You see this in OWL ontologies all the time. I've seen it in a number of ontologies I've consulted on and been asked to review for quality. So a wheel is a part of a car, not a more specific type of car. You don't use the OWL type relationship to represent a wheel being part of a car. This example is harder. This was actually one of the cases, one of the ontologies I consulted on, where they were talking about different portions of a trial as being types of trial. No, they're parts of the trial, right? Okay, they're temporal subparts. Okay, again, danger of a simplistic upper ontology. This is another danger of OWL itself, in that they put a little bit of upper ontology content in the language. They sort of privileged this stuff by creating type and inverse and a few very common relations. But they left out, of course, an immense number of stuff because they wanted to keep it small. And one of those things that they left out was the part of relationship. And so people don't see it in there, and so they misuse an existing relationship fairly often.
Type is not supposed to be subclass. Type is instance of.
Type, yeah. Yeah, I mean, I don't claim to be an OWL expert. I rarely use OWL, so I probably use
type something. That's
yeah.
usually the instance.
So what? There's two of them though, right? Subclass. Okay, thank you. Yeah. Thank you. Yeah, good correction. Okay, modeling events as relations. This one's less common. I like to bring this one up because I think everybody should read Donald Davidson's original paper, or at the very least Terence Parsons' excellent book on representing the linguistic semantics of events. So it was fairly common early on in artificial intelligence to represent verbs as though they were predicates. So say, eats Bill ham sandwich. And this, of course, becomes problematic when you want to say that it occurs on Tuesday that Bill eats a ham sandwich, or that, Terence Parsons' example that Brutus stabbed Caesar with a knife on Tuesday. When you start composing these things, they become very, very awkward. And so much better to do what Davidson suggested, do Davidsonian semantics is now what it's called, of reifying or creating an instance of the event, and then having a constellation of things that modify that event. Ontological promiscuity, it's a lovely name for a very common problem, often derived from language, where people are aware of synonyms in our language, and they assume that every word in English should be a term in their ontology. Big problem. Usually happens when people don't define their terms enough, carefully enough. And that happens all the time in languages that don't allow you to make much of any definition on your terms. And so it's very easy to have these taxonomies that just grow and grow and grow, and nobody's defined precisely how each of those terms differs from any of the other terms, sometimes because they can't do so in the language that they've chosen. So they never discover this problem. So that's a case of confusing language and concept. So I had one fellow argue vehemently that context was a very important concept. And I agreed it was a very important concept. But he wanted it to occur in SUMO. And yet he didn't have any definition for it. It was important. It's important in language. It's an important notion. But if you can't define it precisely, then it actually doesn't belong in a formal ontology. It's embodied in a different way. Context is embodied in the preconditions to many rules on SUMO, for example. But nowhere in SUMO will you see a named term context, because it doesn't belong in there. Modeling roles as classes, this one's fairly common. It's a bit of a judgment call. I've had a lot of interesting discussions around this topic, but at a basic level, human is a class, right? I'm human no matter kind of what happens to me. If I have some terrible accident, I lose both my legs, I'm still human. If I get a different job tomorrow, I'm still human. Hopefully I won't get a different job tomorrow. But so, teacher is a role you have at one point in time. And if my role changes, my identity, my fundamental being, my class doesn't change. Just my role has changed. Failure to reuse. This is sort of an extension of some other things I've talked about. Very common. People love to create their own stuff, especially good programmers. Good, smart programmers love to create from scratch. It takes work to understand somebody else's stuff. Most programmers hate to do it. You usually think, oh gosh, I could have done this better. But it's a fact of life, and we should learn that it's a fact of life in information design as well as software development. Lots of other pitfalls that I could talk about, but sadly, even those basic first ones are so prevalent. I don't think we've gotten to other stuff about how to define modals or normative force. That stuff's too advanced. Most ontologies haven't even begun to consider these notions. SUMO, of course, does, actually. Okay, so I think we're actually out of time. So I would love to discuss these issues further and answer questions, but I guess we have to move.
Well, I have a quick one.
Okay. Moderator's prerogative.
Moderator's prerogative, which is, assuming that you've now created a bunch of disciples who love the idea of SUMO and ontology, how friendly are the tools? Or let me ask it this way. Would you recommend people approach creating or extending an ontology using a controlled vocabulary, a controlled English kind of thing, Adrian Walker style? Or how would you suggest person who may not be trained to think as precisely as those very pitfalls you're talking about could work on creating ontology?
Well, the first thing I'd suggest is this. Get a copy of my book. That is the one thing I sell. So, you know, this past summer, I had 2 summer interns, one of whom had just graduated high school. I sat her down and said, read my book, do the exercises in the book, I'll grade them, and when you're done, then you're ready to start doing some useful work. She was done in about 2.5 weeks. The rest of the summer, she was creating good ontology content in SUMO. If a high school girl, albeit a very bright one, who wound up going to Carnegie Mellon, actually, good plug for you guys, if she can do that, gosh, you know, maybe the rest of you can. It's not that hard. You know, people that say SUMO, oh, this formal logic stuff, much too hard. You know, I'm just going to use OWL and I'm going to do it in Protege because everything else is just too hard. Well, that's silly. It's not too hard. I guess the flip side of that argument also is, you know, there's the joke about the drunk looking under the lamppost because, you know, the light is better there instead of for his keys that are over in the dark alley. Well, it's amazing that people give me this argument about, you know, I can't do that because it must be too hard. Well, you know, if the solution to your problem isn't found there, don't look there. Look in the place that is harder because that's where the solution is. So the solution isn't in creating very simple taxonomies in a language that can't even represent between. Take some time to learn first order logic. That's where the answer is, and you know, now it's not too hard. So there's the book, and of course then there's all the tools and the fact that there's this enormous ontology that's been built to begin with. So you've got a tremendous number of examples to follow. So you can do a lot of, you know, programming standard copy and modify work. So just not that hard. And of course, you know, I'm here to help. Email me if you have trouble. I'm local, yeah.
Any questions? Any other questions?
And I have a book. Did I mention that?
You brought copies. Okay, well, if there aren't, I think we have some time we can spend just outside in the lobby here with some informal discussions, perhaps. And as a token of our appreciation, I have a little gizmo hub here from Carnegie Mellon.
Thank you very much.
Thank you very much.
Cool.
Let's give them a round of applause.
Thank you.
Very good. Every time, you know, I'm wondering if I should.
I haven't convinced you yet. You're getting closer. I can tell.
I'm getting closer. You are. You're right. Chris, I have to apologize to you. This is Chris, who was supposed to be at lunch with us, but I forgot to tell him where we went to lunch. So.
Yeah. Yeah, I just started.
Let's see.
Yes.
Quit and shut, and then I'll go back. I guess I'm supposed to quit.
Seems to work.
I'm so bad though. I just.
Oh, did you email someone else? Is that what happened?
Yes.
Who? Was it someone?
It was Leo,
Oh.
my other student. I said, "Oh, which project am I talking about here?" I emailed Leo, who presumably thought I was crazy.
Was he confused?
Well, he never got back to me, but
Uh-huh.
which makes sense because he wouldn't have known what I was talking about. What lunch? What do you know?
Yeah.
So that was my mistake, completely my mistake. I really feel bad about it, though. But I got a copy of his book for you. Sort of a long-term loan here for 2 semesters. But I'll need it back afterwards, so I'll leave that up front. So that's for you for a while. Exercise. He asks at the end of every chapter, and he's offered, if you have the stomach for it, he suggests you read a chapter, like he just said, with his high school girl. He's willing to grade. If you do the question